Jeff was talking about his cool safety remote.
Well, let me interject something else first. We were talking about that other company you just posted with the. They were talking about Ross too, and I looked at their robots, and you were saying they're nice, but no one has an Ackerman drive system. Well, I was looking at the guy in New Zealand. I think his name's Walter. He was talking about he's got his stuff running on the RG Rover, which I assume is the software and the hardware he's using to run his vehicle. And so if you go watch his YouTube video, he's got this little somebody that created this whole thing has this little vehicle driving around. I thought it's a really nice looking platform. And when I went and looked at it and tracked it down, it turns out you can buy these off the shelf. It's going to probably be a huge link that I post here, but so here is the Razor, what do they call this thing? ATV on eBay. So it turns out you can buy the basic unit for this thing for like $400, and somewhere along the line, I saw another YouTube video where the guy took the existing electric motor off because it's meant to you buy it for your kids, and he put it like a 2 horsepower electric motor on it or something. But I think neither one of them has a differential on the back. So I'm thinking if you buy something like this and then buy that electric transaxle like I put on mine, put those two together, you'd have a very stable system. And it's going to be about half the size of the lawnmowers you guys are working on. So it'd be easier to transport and it'd be all electric. But anyway, I ran across that, so I was just going to post that. Back to what Sohan was saying, yes, I posted that stuff on the Slack channel about my remote control system. And as Greensey pointed out, they bought that one. It's a great system, but it's like $2,000. They paid for just a remote e-stop. And then as Sean pointed out, oh yeah, you're going to spend another $8,000 on top of everything else just to get your safety system set up. Well, that was my approach, the thing on Slack channel there, where I somewhere along the line I decided I wanted a remote control system, and I wanted to basically duplicate what we'd done on our original project we did here. So I just took their specs, and just by looking at their box, I just said, okay, if I get a box about this size and put some joysticks and switches on it. And I had these joysticks that came from a surplus store one time, so I used those. And I found the box is a plastic molded ammo case from Harbor Freight. They put those on sale for $3.99. So I just cut a metal plate to go in there and put my, let's see, can I bring up the pictures here? May as well have that so people can see what I'm talking about here. Slack channel, blah, 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 general. Okay, let me try this. Share that. Share that. Okay, I think that's probably showing up there. That's just the standard. That's just the Slack channel. There's some pictures of my thing that I was putting together. And basically, it's just a plastic box that's got that stuff in it. And as I posted on Slack there, and the description here, I just bought a couple boards from Adafruit to do this. And originally I bought 2 of the boards. One was just the M0 processor and the radio. But then when I got to looking at it, it turns out that M0, the ARM processor M0, does not have a CAN interface in it. So I went back to Adafruit, and I found out you can get an adapter for a Teensy 3.2 that will adapt it to this radio. So so there's 3 boards stacked up on the receiver down here to make that work. And that one, the Teensy, is new enough and big enough that it's got the CAN interface built into it. So let's see, can I do this? So right here, there's a CAN transceiver just stuck on the board. And I've got the Teensy, I just enabled the CAN interface, and I'm programming both the transmitter and the receiver with the Arduino type code to make this work. So somewhere I found the CAN drivers that work with the Teensy. So that's how the receiver part of it works. So I'm able to, if I go back, So here's the main box, and it's this box is nice because it's plastic, so it's lightweight, and you can actually the top will snap on and off. So for storage and transport, you can put the top on and close it, and it latches. And then when you go to use it, you can just take the top off and carry it around. So that works out fairly well. So basically, inside of this box, I've got what I show a couple pictures later, and this battery. So this battery goes inside the transmitter, and I was going to put this key switch on the side, which I haven't done yet. That'll be my on-off switch. And so basically inside the box, so inside the box, this battery plugs right into the little controller board, and I'm going to put the key switch on in between the battery and everything else to make that work. And just here's another view of inside the box. So here's the 2 joysticks on either side, and there's the 3 switches lined up across the top. And this is that little board. So this is the single board that I bought from Adafruit. So it was like $35 for the board. And then all the pieces are plugged in, and there's orange wire sticking up. That's the antenna for that end. And then for the remote side, here's my three boards stacked up to give me my processor here. And I went ahead and soldered on this connector so I can I'll probably run an extension cable from here to the side of my plastic box I mounted in, so the antenna can go on the outside of the box. I could have just put another piece of wire on here, but I thought I might get better characteristics if I put an actual antenna on it. So then I'll have to add just a relay module. So I just need to run a couple wires from there to the relay module to turn that on and off. And other than that, I'll probably put an LED on the box like I did for my control panel. So if you've got the remote e-stop turned on, there will be a red LED on the outside of the box that'll tell you that that's the case, or possibly it'll be green then if it's up and ready to go. It's nice to have those LEDs because if you've got, say, 3 or 4 different ways to do an e-stop on your vehicle, and you go to run it and it won't move, and you have to look at each one and say, is this one on? Is this one on? Is this one on? So it's nice to have those LEDs there just to show up that you've got something going on. And the fact that I put my beacons, let's see, that was under random. So on my beacon here's my red flashing beacon on top of my vehicle right now. So basically, if you have it, so if any e-stop comes on, I could turn on my red lights on my beacon here, so you know you've got a problem. And a little more about this beacon, I was thinking, I've got several colors. It's got this LED right here is an RGB LED, and the one that's turned on, well, actually in this case that's the red one. So if I go back up, here's the orange one. So this was an orange LED, and the other one is an RGB LED. So I can either get, in addition to the orange, I can get red, green, and blue, or I could try to mix the colors, but they don't, since there's no diffusion on it, they don't seem to mix real well. But I was thinking I could define for each color, I could say, send it a message and say, turn on this color, and then either have it be on solid or do a slow flashing or a fast flashing, or I could do have it put out a pattern. So you could say have it count out. So I could say turn on the red and have it count to 1. So I do a slow, I do a quick red and then a long pause and a quick red, or I can do a 3, so I'd flash 3 times and give a pause. So if you wanted to, say in the case of the e-stop, if I hit one of the e-stop switches, then I could go to this mode where it turns red, and then I could have it flash a pattern or a code on there, so you know. So that's another reason you'd know. If I hit the e-stop on the remote, it might say go to red and then flash once, saying that's what I did. Or if I hit the e-stop right here on the vehicle, the one on the control panel, it might put out a count of 2. So you could just do various things by playing with the patterns that it puts out and the colors and so forth. So that's why I was thinking about having just an indication that that's what's happening.
Before you get off of that, would you describe your battery voltage meter you got going on there?
This is that one I bought from that mpja.com, and it's just, so I think I had some better pictures of it here. I guess that, here's one indicator saying I got 85%. So it shows the battery percentage and the battery voltage. So it says 12.8 volts, and this is a little bar graph down here to show you your percentage of battery charge. And I think this little lightning bolt there, I think is a low battery indicator. So if it gets down to where it declares you've got 0% left, I think that's a little red LED that lights up behind that. And then it's got a button on here you can press, and I think it changes from 12 volts, it changes to, I think, temperature. So it tells you what the ambient temperature inside this little box is. And I think normal price is like $8.95, and I think I bought it when they had it on sale for $7.95 or something. And it's just a matter of cutting a square hole in the panel and sticking it in there, and then it's just got 2 wires coming off that are just wired across my battery. So when I turn the main power on, the thing just lights up. It's got a backlight, which you can have it set so when the backlight comes on, it'll stay on for 10 seconds or 30 seconds or something. And I said leave it on all the time, so that gives me an indicator my main power switch is turned on. And since I got this LED on my control panel for the e-stop, that also is a power indicator. So it's either red or green whenever the power is on. So that's a good indication. And then on that e-stop, if I right now, so the e-stop is pressed in, so the LED is red. And if I pop it out, then it's green like this. So that's just an indication. Again, you can tell if that e-stop is on or off. So my remote control box, I'm thinking about putting a red-green LED on that, so you can tell if that one's on or off. And then, like I was saying, then if you hit any e-stop, I can have the red beacon flashing some pattern or something. Say, and the other thing on these patterns, I figured red would indicate any kind of error. So if you're driving along and you go outside of bounds, then you could stop and turn the red indicator on and maybe flash a code. Or if you've got bad communications to the remote, it could flash some codes. So that I was just trying to figure out different ways on the beacon to be able to define a color and come up with various codes or various just different ways to indicate a lot of information with that one device there.
Very neat.
And with the beacon off, it just looks like this. Just looks like a metal box with LEDs glued to it. So, and then the other thing was I kept trying to figure out how can I have these LEDs and be able to see them from any angle. And I finally decided if I put a square box and put them on all 4 sides, because I think I show the one here. Yeah, so from the side here, you can see they're on. I've got the LEDs duplicated on all 4 sides. And then the thing is you can't have anything blocking it or you can't see it. So
Do you recall where you got? Go ahead. I'm sorry.
So I got the GPS on top because again, you want the GPS to have an unobstructed view, but you want to be able to view the beacon from any angle. So basically, I've got the 2 stacked on top of each other there.
Do you recall where you got the metal box from that looks more rugged than, say, just a typical electrical box?
That was also from that MPGA surplus. If you just look under their boxes and enclosures, that's called a die-cast metal box. And they got various sizes. The price seems to go up very quickly because you get some bigger box are like $50 or something. This is like a $3 box. I think this is the smallest one, and it was also close to being square. It's not quite square, but it was close enough for what I wanted. And you can get ones that are longer and you get ones that are taller and various things. So if you look at this, the e-stop and the box and this battery monitor all came from that same surplus company. So in fact, I just placed a couple more orders, and they gave me a phone call at home and said, "Oh, we don't have the heat shrink. What do you want to do about it?" And I got an email saying, "We don't have the heat shrink. We're going to send it to you tomorrow at noon anyway." So there's a little bit of confusion there, but other than that, it seems to be working out.
I see the screws on there, and you've got your GPS obviously on there. What's the assembly sequence? Because I don't know how you get to those screws after you've got your GPS.
Well, there's a bolt that goes. There's a 1/4-inch bolt that goes up. So it's on the bottom of the roll bar here. There's just a piece of wood across here. So there's a bolt that's on the bottom, a bolt and a washer. The bolt goes up through, and this is a threaded adapter because the GPS has a 5/8 inch by 11 threads. That seems to be a standard. And if you buy it from Swift Nav, they come with a little brass thing here that threads into the antenna itself, and then it's got a 1/4-inch hole that's tapped so you can mount it on a tripod is what they make it for. And when I bought this antenna, it didn't come with one of those, so I just bought a bolt, like a 3-inch long bolt, and took a hacksaw and cut it off so I had 1/2 inch of 5/8 threads, and then just drilled a hole and tapped it into my 1/4-inch. So basically the process is you stick the bolt through here, and there's a spacer. There's a plastic spacer that runs the height of this box because I wanted to be able to crank it down tight so that the spacer keeps it from crushing the box. So that's yet one more thing that you have to line that up, and then you have to put the bolt up through there, and you put the box on top, and then you screw this screw this metal adapter on top. And then once you get all that, then you can screw the antenna on top of that. I was thinking about gluing that spacer that's in there. I was thinking about hot gluing it so it doesn't move around, but I haven't got around to doing that yet. So, and it turned out to be a real pain to do this because I've got all this rat's nest of wires coming out of the thing. And I said it'd probably be better to just make like four printed circuit boards, and you can actually buy the LED that's not soldered onto these plates. It turns out they call these on. They say the LED is mounted on a PC board. Well, it turns out these are actually stamped out pieces of aluminum that they're using for heat sink. So the wires on the, see, can I zoom in? So the wires coming out of the end of the LED are soldered to this thing, but this whole thing is just a piece of like, it's not 16th, it might be a 16th of an inch thick, but that's just a stamped out piece of aluminum. So I don't know how they got this pattern on top of the aluminum. So they must have the aluminum and they put some kind of like a paint or some kind of a layer on it. And then they've got the metal on there that the LED soldered down to. But I could probably just make a printed circuit board and just solder the bare LEDs right down to that. So I can make four boards and then solder those all together, and may or may not need a box to do that. I could just get a wood block and just glue them onto that then if I get to that point. So anyway, that was I put a lot of thought into that. I put that off forever, and finally I decided if I get a metal box, and then I was going to stand these up directly, but it turns out the box isn't tall enough to clear the wire, so I had to put them at an angle. And let's see, I don't know if we got a good image of that here.
Do you happen to recall how many watts those lights are?
They're supposed to be 1 watt LEDs, so you can put up to 350 milliamps through an LED. And it turns out the orange ones that I bought, they were single ones. They sent me the wrong ones. They sent me 3 watt LEDs. So putting the same amount of current, they're like 1/3 the brightness. So I had to do a lot of screwing around here. And I ended up putting the 4 orange ones in series. So I've got coming in here the white wires for the orange. And then I've got a wire that you don't see here. I've got a big red wire coming in for the power. So basically, I put the 4 orange LEDs in series. So I got 1 wire coming in on the white, and it daisy chains to all 4 of them, and then goes back out over the main power wire. But I can't do that with the RGB ones because they're common anode, which means I can't get separately to each LED on that. Now, if I'd thought about that ahead of time, you can, when you go to order them, you can get one they call 6-lead RGB LEDs, so all 3 LEDs, all the leads are brought out, and then I could have put those in series. So I had a lot of playing around I had to do there to make that work. So what I'm going to have to do when I go to make the driver box, which is basically for each color, there'll be a transistor and a current limiting resistor, and there I can adjust the current up and down to get whatever brightness I want. And the whole point is I want to be able to have this thing out in bright sunlight and still be able to see the LEDs. And that's another reason to have the LED. You're basically looking directly into the LED. We go back to like right here. This is a good example here. This orange LED right there. You're looking straight into that, and it's supposed to have a 120-degree field of view. So regardless what angle you're looking at it from, so like this red one here, so you can see both of these from, we're almost at a 45-degree angle to it, and we're not looking directly into either one. So I'm thinking that will work from, whatever angle you're at, you'll be able to see at least see they're on. They may not be real blinding, but that's something I can play with. And then the other thing I thought was I'm going to try to make them as bright as I can within reason, without stuff getting hot. And then I'm going to put a photo sensor somewhere on it. So I have the photo sensor sticking up to see the ambient light conditions. So if you have it in the office environment, it's going to be darker than it is out in the full sunlight. So it's going to be, it won't be as bright inside the building, because everybody's going to complain about that. Oh, it's too bright. You can't have that. So that'll dim it down. And if you're driving around at night, you can figure out what kind of response curve to have. But then when you're driving around down at night, you can dim them down quite a bit, because you can still see them in, it's totally dark out. You'll be able to see them really well. So that's just kind of the progress I've made on that. And as I say, I'm trying to come up with patterns to represent lots of information, and then get it so it automatically, the brightness goes up and down, and I'll see how that works out.
Can you look at that 6-lead LED that I just posted in the chat and see if you had to do it again, would is that the sort of thing you would recommend? And I don't know the product. I just Googled it while you were talking.
Yeah, I went to eBay and I typed it because I wanted big bright ones. Does it say how much power this one is? These
I
are
was looking
probably
for watts. I didn't see it, but
these are probably just little tiny surface mount ones you put on a normal board. So you probably put like 20 milliamps through, and they might be, I don't know, they rate them in mini candela. Yeah, right here. These aren't very bright. These are
if forward current 20 milliamps.
Yeah, and right here where it says luminous intensity, it says 700, 1350, or 160 millicandela, and the ones that I have, I think, are actually rated in lumens there, which is incredibly brighter. But if you just go to eBay and search for 1 watt LED, and most things are trying to sell you stuff to put on your car. Let's see if I can find one here quickly.
The only reason I'm asking is it sounded like you had some learnings there that others who want to.
Yeah, I wouldn't rush into this yet. Let me get this finished up before I make any recommendations on what to use.
Yeah, bling is not my priority.
Well, it's much more than that though, because it is a static.
I know. After I said that, I'm like,
system.
no, this is like I would like to have an LED. Do I still have RTK? Right.
And then the other thing I'm still thinking about is putting on a LED strip. You get those addressable LEDs, and basically you buy a roll that's a meter or 5 meters long, and you cut off whatever piece you want, and you can have, I don't know, maybe in the width of my roll bar about like that, I can get like 20 or 30 LEDs across there, and they're all addressable. So number one, you can say, take the LED on the left, we'll call it LED number 1, we'll say, well, that's going to be tied to my Verizon hotspot, and if I have an internet connection, if I have no internet connection, that'll be off, and if I have an internet connection, it could be one color, and if it's receiving correction data from my GPS, it can be another color. And take the next LED and say, that's my first U-Blocks receiver, and again, if we're not talking to it at all, that can be off, and if we're talking to it, and it's got a single point fix, it could be one color. If it's an RTK fix, it'd be another color.
Yeah.
And that way you can just randomly assign those to anything you want. So I was watching the stuff from AgOpen GPS yesterday, and I was noticing across the top of his screen, he's got what they call a light bar. So you can tell, what the angle is, what the steering is, just by watching it. And if you have that LED strip, you just have another mode that just pops up, and that becomes your light bar, where if you're going straight, you'd have the one LED right in the middle turned on. I think they had a yellow one. And then go in one direction, they would get red, and go in the other direction, they get green. So again, that's just another thing that you could, just by flipping a bit in your code, you can say turn it into a light bar, so as it's driving along, you can watch to see what the steering's doing as you're driving along. So that's another thing that could be, you could put on your vehicle, and it doesn't have to be, it can be totally separate. You just have to put in vehicle power and then put in some kind of communication. So either a CAN bus, or you could even go directly USB back to whatever your main computer is, and talk to it that way. And basically you say, turn on LED number 3, this color, and that should work. So that's another cute thing that you could put onto anything. It's just a status indicator that you can plug it into either your little computer or your big computer, depending what kind of interface you want to run on that. So that's something else to keep in mind. And I haven't got that put together. I did a little test one time that had 8 LEDs on, and had it on just one of the little, like, Arduino Nanos, and it seemed to work just fine. And so I'll probably try to get around and do that. So I might put that on across the back of my roll bar. I might put, so it'll be between the beacon on the top and my control panel. So there'll be a strip there that'll have all these LEDs that are, again, totally addressable, and you can put any status on the things you want. And if nothing else, you want just bling, you can make a pattern that zooms back and forth and fades up and down, and all kinds of fun stuff.
I think your status lighting ideas are great. Actually, like I said, it would be nice, in addition to the internet thing, whether or not RTK is holding a fix, as an example. So,
and basically, you've got enough LEDs. You can, anything you want at a moment's notice that, well, I'm going to take half of them, make a bar graph to show, say, maybe satellite intensity or vehicle speed or anything you want to put on there. You know, you can basically just write up little functions to do any of these different types of things and just stick them right on there. So that should work out. And I still haven't got my turn signals and stop brake lights put on yet. So, and that's something else. Those will just automatically work based on if you tell the vehicle to go forward, either forward or backward, your brake lights will turn off. And then when you come to a stop, they'll turn back on. And if the steering says we need to turn to the right, then your right turn signal can come on. So again, that's just more indication that people expect they're on. Say if you're driving a car, or even our tractor had turn signals and brake lights on it. So that's just something else you can add on there that essentially will just take care of itself. You know, if you just get the right, you look at your command velocity message, and based on that, you can control your turn signals and brake lights based on that.
You got a reaction out of Matt, so that must be really important to him.
Yeah. Well, I noticed that after I was showing pictures of my painted robot, I noticed Matt's lawnmower seemed to get painted somewhere along the line.
Jeff, you're really just like raising the bar.
Well, I've noticed over the years that, you know, everybody seems to build robots, but they just, you know, slap them together and hot glue them and whatever. And then I show up with my stuff that's all painted in a certain color, and they go, oh, yeah. So, yeah, I tend to intimidate people into painting the robots. So, well, we'll see how that all works out.
That's really cool, man.
So let's see. I did mention that ATV, that $400 ATV. Yeah, I mentioned that. And we talked about my remote control thing. We talked about my lights. Anything else I should talk about here?
I just shared
remote control. You must have had some software on that. Are you open to sharing the software that's on that?
I am. I gotta get it running first. So, and hopefully tonight I can work on the software on the tractor end of it and get that so it can accept the data coming in. And
curiosity, the joysticks, are they spring loaded so that they're always wanting to return to zero, or?
They are, and when you buy joysticks, sometimes you can get ones that either have a spring or don't have a spring, and sometimes they'll have a little lever on there. You can flip the lever and make each axis either spring return or not. So just depending when you buy the joystick, that's going to control that.
I mean, I guess it comes down to a personal preference, but to me, there was always a fatigue factor of things that came back to zero. And for Ackerman steering, it just, I don't know, for me, it was, I'd rather not have one that was spring loaded coming back to zero for the steering joystick anyway.
Yeah, I think it just all depends on when you buy the joystick. You got to look at it and see if it'll allow you to do that, and sometimes they'll just have a physical spring on there. Just take some tweezers and pop the spring off, and that way you can make it do whatever you want. It's just something like speed. You don't want speed to stay. You want that if you let go of it, you want the speed to slow to zero and come to a stop.
Right.
So that on each individual case, you got to decide what you want to do on that.
Are those joysticks canned?
The joysticks are just have pots on them, so it's just like, just a standard off-the-shelf joystick. They look like they're out of the ones, the radio control airplane ones. That's what they look like. And again, back to this mpgaa.com surplus place, they have ones that are like that, the same size for $20, but it's also got a knob on it, so it's not only X, Y, but then you can turn the knob to. So you basically get three pots coming off one joystick, and you'd have to look at them and see if those you can defeat the springs in those or not. So probably if I do another one, because these are the only two that I have that are just rounded up somewhere, but that's somewhere you can go online and buy them, or you can get the little tiny ones too, the little thumb type joysticks like you'd find on a gamepad type thing. You can buy those too for, I think SparkFun has those for like $5, and so that'd be another way to do that. But as far as the software and everything in there, it's just a matter of the board itself acts like an Arduino, and I'm using the Arduino IDE on it, and I just went out and got the radio library. There's apparently a standard library to talk these kind of radios, and I loaded that in, and the radios seem to be working, and then I could just read just using standard Arduino type stuff, I'd say read the analog inputs for the joysticks, stick those into my message. And this is not a CAN message, it's the radio message. So I just basically said, you know, take my 4 joystick axes, and then packed my switches into a few bits and sent that across to the receiver radio. And at that point it says, okay, here's a callback saying I just got the data. And then at that point, you just do whatever you want with it. You can either send it directly out the USB port. If you're going to hook it up, if you're going to plug it right in your main computer, you could just use the USB on your receiving board and send it out that way. Or I chose to get the Teensy, which has the CAN peripheral, and I've got the CAN transceiver. So that one also, somewhere I found the Arduino code to talk to that CAN interface. And I guess the other points on that. So it's really just a matter of defining it, you know, deciding what you want it to do, and just working through it step by step to get it to run. But there are things we have to do as far, you know, from a safety standpoint. Say, well, if I don't receive a message within a certain amount of time, or I should put a CRC on every message that goes across. And if you decide that the data coming across isn't exactly right, then you should activate your eStop relay at the other end. So it's constantly watching a whole list of things that if any of them don't match, then you can shut the thing down.
I'm trying to understand the use of CAN interface here. Is that just because Danfoss uses it and you wanted to replicate that, or I'm trying to figure out why you have that CAN interface and what you're trying to use it for.
That's why I went with CAN, is because everything at Danfoss is CAN. In fact, here's one of the controllers right here, and this one is set up. It's got the power and the CAN in and out of it. They're just simply using this as a controller to drive a vehicle around. They're writing up what they call their autonomous vehicle modules. So when you run the software, you can drop in modules to say read the GPS, one to say fuse your odometry and stuff, and then they've got a path follower module in that. And basically, so this box is just acting as a microcontroller, and it's got a CAN interface. So if I wanted to interact with the stuff here at Danfoss, I have to have a CAN interface. And the other point was the remote control that I was patterned this after, they had an eStop relay and a CAN interface. So basically I want it to the point where I want my remote to talk directly to my low-level microcontroller, and I'm going to have a CAN bus in there anyway to talk to this controller, or I could talk to my main computer over CAN. So basically that's why I ended up going with a CAN interface on it. If I didn't have that requirement, I'd probably just take the one of the UARTs on that Teensy board and tie it to the UART on my microcontroller. Or if I got really ambitious, I could have just put the radio right onto my microcontroller anyway, not had a separate microcontroller to do that. Because I've got that, it's a Cortex M4 eval board, and it just needs an SPI bus to talk to the radio. So I could have wired it directly into my main microcontroller, and I could have got by that way too. But I was trying to get to the point where it basically I could unplug this one and plug in the commercial one, or vice versa. Just be able to interchange them back and forth is what I was trying to come up with on this.
Very cool.
That's great.
And I see someone posted something here on a 10-watt flashing beacon. And
Oh, yes.
These are nice, but I wanted the multiple colors. That's one of I wanted to have the multiple colors and to be able to program it for all these different patterns that I was talking about.
Right. No, this one would be cool if we just put it in, and if the vehicle's performing an autonomous mission, this just turns on when it's going autonomously, just as an indicator of it being autonomous. That's it.
Yes, and it turns out that a standard commercial vehicle, they have the orange flashing light. So when somebody's on the thing driving around, it flashes orange. But it turns out somewhere it says, but if it's autonomous, it's supposed to be a blue flashing light. So that was one requirement of why I had to go to multiple colors to start with. And then I thought, well, if I'm going to put RGB and then orange on there, the reason I bought a separate orange LED was I didn't know if I could get my RGB to give me a decent orange. Again, as I say, they're not diffused LEDs. You could actually see the individual LEDs when you turn it on. I might be able to get a decent orange out of it, in which case that's going to save having to add that extra part. So that's something I can look into and see what happens on that. And it'd be nice because I know on one of the vehicles we've got, they went out and bought something similar to this one you posted here, but it was actually a multiple color one. And I think you'd go in and you'd program the thing and say, do you want it to be blue or do you want it to be orange? And then they might have had various patterns. You can do a slow flash or a fast flash or something like that. So there are various things. And this is handy to be able to just buy something like this and just plug it in and have it work. That's real. That's very, that's much better than what I'm trying to do, trying to build all this stuff from scratch, because it's getting to be a real pain to do that.
I was just looking at the price, and it was like $10, and I'm like, yeah, that seems nice. That's feasible.
And it probably just wants to run off a 12-volt supply, so you just hook it up to whatever you have. That, say, like on the garden tractor type thing, you could just hook it right to your 12-volt battery, or maybe have it switched with a relay or something, so you can have it just turn on and off. And probably it's going to be easiest to buy these in the orange color, because that was always the safety color that people would recommend for vehicles. But if you do need to go with blue, then you might maybe search hard enough, you can find one that is in blue. Or, as they say, the ones on the second tractor they actually built down in Ames, they found one that they bought it and actually had the multiple colors there. I'm sure they had paid like $120 or something for it, but I think they had dip switches. You can set the color you want it to be, or maybe it had, say, like 4 different signals coming in. So you turn on the red one or the green one or the blue one or the orange one or whatever. That might be another way to do that. Mm. And the one he posted, that's a good example. If I could have found a plastic piece to go over the top that would diffuse my LED like that, maybe I wouldn't have had to put LEDs pointing all the different directions. But I got tired of experimenting with that and just decided it'd be easiest if you're looking directly into the LED, that'd be the best chance of being able to see it. So that's why I built it the way I did.
Very neat. Jeff, anything else to share?
Not that I can think of right hand.
Jeff, you mentioned on that 4x4 Razor ATV, you said something about swapping out the motors or the axle or something.
Yeah, if you go look at it, it turns out in the back it just has I think it's got a solid axle that goes across. So it's got bearings bolted to the frame. That's got the wheels stuck on that, and I think they just have a one solid gear on there. So it's a live axle. Whereas if you're doing anything, especially if you're trying to model an Ackerman drive and you want it to work well, you really need a differential in the back. Okay. So if you, like on mine, on my previous one, my first mini tractor that I built, I had this differential I bought on eBay, and I put that in there, and that way it's just like a car or a tractor, that they all have differentials. And the reason you have that is because as you're turning a curve, one of your back tires has to turn faster than the other one for it to work. And if you've got a solid axle across there, one of your tires has to skid as you turn. So you find, like on go-karts, they don't bother with a differential. They just run a solid axle across there. And that does work. And this thing being not really high priced, $400 is still more than I'd like to spend, but they didn't want to spend the extra money to put a differential in there. At least just the pictures I've seen, because if you go look on eBay, you can find pictures of this all over the place. And the one guy that somebody on YouTube said, yeah, I built a autonomous vehicle and I took off the little motor. It's like a 200 watt or 400 watt motor, and he put on this one that said it's like rated at 2 horsepower. So it's a really big motor they put on the thing, and that will have no problem, pushing the thing. Even if the tires are trying to skid, it's going to have no problem pushing it. It's just that your steering doesn't want to turn if your 2 back tires or have friction with the ground. So that's why you want to put a differential in the back if you can. And that's why it's saying if you just unbolt what they have there for their axle and buy one of those transaxles like I have, which has the motor, the gear reduction, and a differential all built into one unit that you just bolted onto the frame, that would make a nice, a quick way to give you the entire frame with the steering, and plus then replace the back end with this better drive solution than what they have.
Okay.
And if you look at, I think the one that original YouTube video I posted, the guy, I think he just had a linear actuator tied to the, because originally it had handlebars, just like a motorcycle or whatever. And he took that off and just welded an arm on there and put his linear actuator to turn the steering back and forth. And in order to get fast enough steering, I think he said he used a 2-inch stroke linear actuator. So that's going to be faster than the ones I bought that are 4-inch, because they move at the same rate, but if you have to go full 4 inches, it takes twice as long to get there. And then somebody else was talking about, I think they just put a motor on or something. So if you look on YouTube, people have been modifying these to make little autonomous vehicles. So there's more information if you search on those.
So I noticed you mentioned motors as in plural. I mean, does that suggest that these Razor ATVs have two motors, or is it just one axle and just one motor sitting in the back? Because if it has two motors, we can, drive them differentially with software.
This particular one looks like it has just a solid axle and a single motor that's driving it. And if you wanted to, you could, I'd say, take that off and put two motors to drive it in the back. And I think if I were going to try to do it with two motors, I wouldn't try to drive them differential. I'd either put the two motors, wire them in parallel, or wire them in series. And then as you apply power to it, just mechanically and electrically, just automatically, one side will turn faster than the other, and I think that'll take care of itself. But if you're doing it mechanically, if you just have a solid axle, then one of the tires has to skid as you turn. But if you put a differential, then that automatically takes care of that. But yes, you could if you could find a convenient way to get two motors. A lot of people use the wheelchair motors, where it's basically like what I have, but mine is made to put two wheels on. But you can get a wheelchair motor that's basically a motor, a gear reduction, and then a place to bolt your wheel right onto it. So you could put one of those on each side. So it's just like they do the wheelchairs. But I don't think you have to go to the trouble of actually driving them differentially. I think you just put power on them, and just the way electric motors work, the less load it has, the faster it's going to turn. So I think that will automatically take care of itself. Now, if you have encoders on both motors, then you get advantage of, you get the you can do differential odometry coming off the two motors. So that would still be an advantage to doing that.
I've used these RoboClaw controllers. These controllers, what they essentially do is they take in a CMD well message from ROS. They come with a ROS driver, and they do differential. They do all the calculations on board itself, and you can. They have a software on Windows, so you have to set it up beforehand. But once set up, all you have to do is send in CMD well messages. Now, with the CMD well, if you're turning, the CMD well message has this information. So the controller takes in that message and generates output for each of these two motors to drive it differentially. And you can set these things on that software. So you won't really necessarily, I mean, it's pretty neat how they thought of it. I just find it's a costly driver or costly controller, but it does the job really well. And since it has an automated speed controller, so if you have encoders on your motors, well, you need to have encoders if you want to use this CMD well thing, but it has input for encoders, and it reads motor speed, so it's pretty neat, and it's really robust, and it's a system on its own. It's pretty cool.
And everything you say there is true. But if you're going to run a differential drive robot with, say, a caster wheel, that all works perfectly. But now if you're going to run an Ackerman drive vehicle, you want the front wheels actually controlling your full kinematics. So number one, the two would be fighting each other. If you either they're going to be fighting each other, you're going to have to do a lot of extra math, I think, to get your back wheels to control them differentially to match whatever your steering is doing in the front. So I don't think that's really going to be, I don't think you'd want to do that in this application. I think you want to either run the steering in the front with your Ackerman and have that control everything, or do differential drive in the back and just have a caster wheel instead of having the Ackerman drive. So I don't think you want to try to mix those two. And I'm just thinking if you got two motors in the back and either put them in series or parallel, I think that'll just magically work itself out. And now don't get me wrong. I'm not saying everybody should go out and buy one of these and start modifying. I'm just saying that's something I noticed. So I don't want to fill people's heads with great ideas here. They're going to go down this path and waste all their time doing this. I'm just saying, yeah, it's something I saw, and it would have saved me a lot of time since I insist on building mine from scratch. So, but no, I'm not suggesting you go out and try to build one of these.
Mm-hmm. It's worth consideration. But I really like the lawn tractor platform. It has no bounds in terms of battery life. Batteries tend to cost a lot. It just runs on gas. So if I were to ever build something, I would at this moment I would still prefer building something that runs on gas and save $1,000 on batteries. It's in itself. If you try to go for the lithium-ion ones, they're costly.
You still have a whole list of things you have to consider, because if you're ever going to try to drive it around inside of your house or inside of a building, inside of an office building, you can't use a gasoline engine there, so it has to be electric. But as soon as you take it outside, you're right, you can get basically infinite range as long as you keep the gas tank filled outside. So there's lots of things to consider back and forth here to figure out. Or you could build a hybrid system where you have electric motors to drive it, but then you have a gasoline engine driving a generator or alternator. So when you take it outside, then you start up the engine, and then that gives you infinite range, but you can still drive inside it and run it on batteries to drive around. So that's yet another option. So as I say, there's lots of things to think about here.
Mm-hmm.
Matt, anything to share today?
I am fascinated with sensors, and this is the RealSense. It's the T265. I got a quick demo, but the thing that amazes me about technology in ROS is so visual odometry is like visual SLAM is a hard problem in computers. But this little thing, it has two fisheye lenses, and it has a Bosch IMU, and it has a neural compute stick.
Good grief.
All in one thing.
Does it cost about $1 million?
And it's $200, which is pretty expensive, but for what it does, it's phenomenal. Like the software itself is a ton. I don't know if you can see if I've got a.
I can see a fisheye looking at a computer.
Okay. Yeah, so it has dual things, and then you can see it moving around. I mean, so the goal is like if you were going to drive your lawn tractor into your barn to park it, or if you wanted to go out to the field, what we need is be able to switch between the GPS and this device. So this does an excellent job of tracking.
I don't know about the other guys, but the sharing seems to be frozen. I can see your video, but the 3D model, I see your cursor, but I don't see any movement.
Oh, crap. RViz. So I was just showing RViz.
I think sometimes if you share your entire screen and not just one window, I think it works. If
How's that?
There, there. Now it's moving.
Seeing movement.
The tracking is pretty good. Obviously, it's not totally perfect, but it may be good enough to get your robot into the barn, get your robot out of the barn, out to the field, and move around. Or if you're under a tree, for a period of time.
What's the output from the thing?
The output is this is an odometry message in ROS.
Wow.
And you can, yeah, wow, right? Like you could put this, I haven't tested this outside. This is just initially going, but phenomenal. Or imagine this on an end effector. So now you're moving your arm around. We haven't gone to harvesting yet, but I mean, think about that. You would absolutely know where your arm is as you're moving it around, which is a hard problem in robotics. So, and then the other thing, go ahead.
I see two frames on there, one smaller and one bigger. What do they represent on the RViz screen?
Origin. So this big axis, two frames. You see the one at the original one right here, or the one that's moving?
So both of them are moving. They're both on top of each other, but there's like one is a smaller one and the other one's bigger one.
Okay, so one's instantaneous and then one's called a keyframe. So the keyframe is constantly updating and matching back. It's part of part of SLAM, Visual SLAM, is to have these keyframes where it indexes. So it could be indexing at, let's say, 1 hertz, and then you'll have an instantaneous measurement. And then, so since you have 2 cameras, I was like, okay, why can't we do depth, right? We have 2 cameras, we can do depth with that. And sure enough, somebody already wrote software that will combine these 2 things and give us depth. Now, I don't know how all this stuff works, but I am able to run the ROS nodes and get it working. So here is an example of a depth camera. So this is the fisheye lens on the left-hand side, but they use OpenCV to somehow make it look normal. And then on the right-hand side, you can see depth. So that's my finger pointing at that. Really noisy, and you have to be up close. Like this doesn't work. So I'm probably 2 feet away. You can barely see the mug. And then as you're moving closer, you get to see it. So again,
what's the minimum distance? Or have you figured out? So what's the minimum distance to be able to classify objects if you've played around? So how far is your camera at this point?
I am probably a 1.5 feet, 2 feet. So like this is a width of a laptop. And here's, so maybe 2 feet away and it loses it. Again, not as good as their other cameras. So they have, the other thing is the distance between the eyes is really small, which is a factor on your accuracy, on your depth. But as an end effector, I think that there are some things that it could be dual use there. But I mean, this is mainly for visual odometry. This is sort of like it wasn't designed for depth, but you can use it for depth as long as you're close. I don't know, just pretty amazing, the technology and then the software that's available.
I mean, you were thinking the use case about driving in a confined area. Any other use cases that you thought of?
Just a backup for odometry. So another source of odometry, if we get underneath trees or get underneath the power line, there's a lot of little edge cases where GPSs start to fail. And I think that this, with combination with that F9P and this device, I think we could go anywhere. We could go indoor, outdoor, no problem. Or underneath, or like in an orchard, or if you have a skips.
Super cool. Do you think it's the limitation of depth is because of the lenses on the cameras being fisheye? Do you think that could affect it? Or
I don't know. That's a good question. I don't know how that all works. I did hear that the spacing between the eyes makes a difference, and then probably focal length or something with the cameras. Or lenses.
Something to think about. Yeah,
what would you guess? I mean, I don't know if you could fire it back up, but if you just went around a known distance, it would be interesting to see what's the accuracy level. So if you took that and went around the edge of the computer, what would be the measurements of the square that it would draw?
It's really good just moving it around here. I did take it outside and then walk around and then come back in, and I did notice about a meter error. So what I want to do now is get this on the lawn tractor, so I have the GPS, a really accurate way to measure that, and then kind of do some testing. I just got this working, but I haven't done any testing with it.
So what are you using to draw the map? Is that the RTAB map?
No, this is, so the output of this sensor is an ODOM message. And so I would compare that ODOM message with the
Right.
GPS position.
Oh, okay, yeah, makes sense. Yeah. In terms of, so this is ODOM message, and it will also convert to UTM, and then the GPS also converts to UTM. So is that how you try to find difference between those UTM coordinates? Or?
Yeah, you would want to convert your GPS into local coordinates, and then UTM, and then compare.
Yeah, I used UTM, but I meant local.
Mm-hmm. Yep. I just use local because the number is smaller, but
Yes.
yeah, you can.
Also, you don't have to deal with zones and stuff.
Maybe less professional, but a little simpler.
If it works, it works. It's really cool. Yeah, I didn't know about this camera. Thanks for sharing.
On one of the videos they just posted from Homebrew Robotics, one of them, a guy is going through, he built a small robot. It's got like 4 computers. He's got like a NVIDIA TX2 and a NVIDIA Nano and probably a couple Raspberry Pis, and he's got various cameras like that and stuff on it. He was given a talk on that, and here's the link to that. And
The Homebrew Robotics, what are they talking about, Jeff?
just a second here. This is a video of their monthly meeting that they have, and one of the guys was talking about, he's showing his robot that he built, and the first link is just the YouTube channel. It's got all their stuff for the past several years, and the second link I just posted was, if you look at the show and tell 3 for May, about a third of the way through, the guy starts talking about this robot that he made. So it's, and he says, unfortunately, he either forgot the power supply or forgot something, so he doesn't give an actual demo of it. He said that'll have to wait for another meeting, but it's interesting to see, because he's got a couple of the RealSense cameras on the front of it, and he's saying that the motors he used work out great, but I don't think he ever tells which motors they were. So it's just something else. And if you dig through the Homebrew Robotics videos, they've got some pretty interesting stuff. These guys are right out in Silicon Valley, and they've got all the, and they meet at Google, or they used to meet at Google. So they have lots of people that show up for their meetings. So it's interesting to go through and watch their stuff.
Cool. Well, we're after the hour. Jim or Soen, did you have anything that you wanted to share quickly?
No, it's a great meeting, Jeff. You made a lot of progress. Looks really good. Inspirational, actually.
Soen, anything?
Not really, no. I've been trying to learn mobile app stuff, so just playing with Flutter and stuff like that. So nothing really in particular to robotics.
Cool. Just briefly for me, trying to get my odometry worked out in the software phase, calculating speed based on ticks. This particular unit does 3 revolutions for 1 revolution of the tire, so it's a couple 100,000 ticks in order to get 1 revolution of the tire. Need to add some more software in there to obviously publish whatever. I mean, Matt, I'm still thinking I'm going to publish my my speed in minutes and meters per second, and that's the message. It's not going to publish ticks. It's going to publish meters per per second, and that will then get ingested into, I guess, ODOM somewhere along the way. So that's where I'm spending my time. And then Matt shamed me into getting a new computer. So he told me this is what I had to buy. So that's what I bought. It was a used Lenovo W530. This is a little bit of false advertising. Not a little bit, but a lot of false advertising. It's not a 3.6, but it is like a 2.8 gigahertz machine, 16 gigabytes of RAM, low Litco price of $475. So
It's pretty cool.
yeah, so a decent beefy machine to hopefully speed me along. Matt said I would get done faster if I had a faster computer. So we'll see if he's if
Accurate.
that's all accurate. So I have 3 on order, because he's
Wow.
bigger computer, I'll go faster.
Well, you could be much faster if you get Matt to do it for you.
I like that idea.
You're just not thinking hard enough.
I like that idea. See, Jeff, that's why you're here, man. You just you're our guidepost. What do we do? What do we need to do?
I paid $325 for mine, but I got it at a discount, and it's been very good. Very good for ROS development.
So, anyway, that's what's going on in my world.
Awesome.
Okay, guys. Well, have a great weekend and good luck in your development efforts. Stay safe. Safety first. We'll talk to you later.
Say one last question for Jeff. Is that Marlin P. Jones? Is that the gold mine for surplus that you were referring to earlier?
That's the company. Yeah.
One of them. Okay. All right. Yeah, I think someone posted it. I just wanted to double check. That's where you found your battery life meter and all that.
Yeah, the link is definitely in the chat. I'm looking at it now.
Yep.
That's
no,
good.
Just clarifying.
Oh, I see it. Yeah, that's the one. And if you get on their mailing list, once a week they send out specials, and so I usually shop their specials. And you can go back. They don't say so, but you can go back like 3 weeks, and so keep your emails, and you can go back and then add stuff together on the different specials that come out, and then place your order. And their gimmick is all the shipping is $6.95. So no matter what you buy, if you buy one resistor or you buy a whole box of stuff like I usually do, it still costs you $6.95 for shipping.
Okay. Thanks.
Have a great weekend, guys. We'll talk to you later.
Okay.
Okay, you bet. See ya.
Wait for I have one thing. I just found I just got an email from the ROS groups. We talked about safety the last time, and Kirky had sent a link to a document which I had shared earlier in the Slack channel, and I just found an update from Sean Schrader. He's from North Star Robotics, and he shared his views on the document that was written by Mercedes and a lot of car companies in general. And he says, and I'm just trying to find a link so I can share it and include it in the thing in our chat. Just give me a second here. Okay, sorry, I didn't mean to keep you guys waiting, but I just thought it would be nice to just have it included in the meeting.
You're talking about the Daimler Benz one you posted yesterday?
Yes. Yeah. Did you get the email for that?
I don't see the link yet.
Just give me a second here.
I can't remember which category you posted that in. Let me look.
Under random.
Oh, my bad. It's really important, but okay. Yeah, I read through some of it, and I think that's true. It is mostly defined for autonomous cars, so we might have to work on bringing something out. I saw some of the things that we could use for the lawn tractor platform in particular, but nothing that you can generalize for ROS. So something to talk about in the next safety meeting. Yeah. Yeah, that's all I have. I just saw this and think it's worthwhile. It was worth a mention. Apologies for dragging the
That's
meeting
okay.
longer.
So, yeah, I mean, I saw the Daimler document. It would be interesting to see somebody's comments about what they thought of the Daimler document. I was looking to see where you had posted that in random. I'm still scrolling up through random, but I don't see it.
What I saw in random was just at the very bottom there. It just said, "Here's the different levels of autonomy."
Yes.
That wasn't a PDF. It was just a picture.
If you use if you see the Zoom chat, I just shared the link again. So you'll be able to find it there. This levels of autonomy was something that is related to this. While I thought about this while I was reading the document or going through it at least, and I found that these levels of autonomy for vehicles like cars, they're really different from what we considered for what we need to consider for robots. We don't need 5 levels, and I think that's another discussion about safety that's important because with autonomous vehicles and autonomous tractors and other robots, I feel they fall in different categories, as in there's an operator always, and autonomous robots, well, our goal is for them to work autonomously and not have an operator at all times. So also there's a lot of safety concern when you're inside the machine that's operating autonomously and you're not inside it. So that's a different story, but yeah, just a few thoughts. Yeah.
Okay, guys. See you next Tuesday.
All right. Weekend.
Okay, bye.
Ciao.